Good evening, everyone. So, as you know, that today we are going to do the CBSE PYQs of our chapter Electrochemistry. So, hope you are very well. And previously, we have studied whole theory of the chapter Electrochemistry, and we have been also covered some NCRT exemplar questions regarding the chapter electrochemistry, right? So today our topic is CBSE PYQs, that is CBSE previous year questions. So let's start. Disclaimer: the images, text, and other materials used in our presentations are for educational purposes only. We respect the intellectual property rights of original creators and owners. If you are the owner and have any concern or issues, please contact us at sathi@iitk.ac.in and we shall remove the content immediately. Please note that the parts of the content may have been generated using generative AI, which is experimental. So let's start with the first question, and this question is a CBSE PYQ. This covers the NCRT section 2.4.2 in the NCRT textbook in electrochemistry chapter. The question says that Debye-Huckel on Seger equation for the strong electrolytes, which is this, lambda equals to lambda naught minus a under root c. Which of the following equality holds? So in the question we have given the Debye-Huckel on Seger equation, and then we have asked that in the given options which equality is the correct one. You have to tell that. This question has been in the CBSE examination for the Delhi Set 2 in the 2020. The four options are lambda equals to lambda naught as C, that is concentration is corresponding to or approaching to under root A. Lambda equals to lambda naught as concentration is approaching to infinity. Lambda equals to lambda naught as concentration is approaching to the 0, or lambda equals to lambda naught as the concentration is approaching to 1. So you have to select on the basis of the Debye-Huckel on Seger equation that which option is the correct one. You got some time, go through this question, try to solve it and try to figure out that which is the correct option, which is the equality. Try to equate the concentration values which is already given in our options with the Debye-Huckel and Seger equation, and then you can identify the answer. So this is a little hint. Then we will see the correct answer. Okay, now let's see. So for this given question, the correct answer is option C. That is, lambda value is equals to lambda naught as our C, that is concentration, is approaching 0 value. Now if you can solve it. So we have equation of Debye-Huckel on Seger, which is lambda equals to lambda naught minus a under root c, right? Now the equation shows that as C will approach to 0, right? That means concentration in this equation, C is representing the concentration. So as C is approaching 0 value, that is concentration is becoming 0. That means our solution is becoming less and less and less concentrated to 0 concentrated. That means we are getting infinite dilution, right? That means the amount of the solvent is increasing. The dilution is increasing. We are getting concentration as 0 and dilution as infinite, right? So this equation shows that as the C is approaching 0 value, so lambda is equals to lambda naught minus A under root C. If C will become 0, under root C will also be 0, right? That means this term in the negative sign will eliminate in this equation, and lambda will become equals to lambda naught. So lambda equals to lambda naught in this case. So the equality that holds is that lambda will approach to the lambda naught. That means lambda equals to lambda naught as C equals to 0, as C will approach to 0. This means the molar conductivity approaches its maximum value, which is lambda naught at the infinite dilution. Okay, which is kind of not the standard thing, but this equality which we are getting, that is lambda equals to lambda naught as we are approaching the concentration to the 0, that means we are infiniting the dilution process. So the molar conductivity, that is lambda, approaching its maximum value, which is lambda naught. Because why we are saying it as a maximum value, because according to the equation of the Debye-Huckel Onsager, lambda equals to lambda naught minus A under root C, right? So lambda equals to the difference of the two terms, right? Difference of two terms, lambda naught and A under root C. Okay, that means A under root C is subtracting from the lambda naught, right? The maximum possible value for the lambda will be this lambda naught alone. If anything is not subtracting from the lambda naught, then that will be the maximum value for the lambda, right? That's why we are saying that molar conductivity is approaching its maximum value lambda naught at the infinite dilution. And hence we have our correct answer as option C, that is lambda equals to lambda naught as C is approaching to the 0. Okay, so hope you understand this. Let's move to the next question. Okay, so this is again a CBSE PYQ which is based on the NCERT section 2.4.2 already given in the electrochemistry chapter in the NCERT textbook. The question says that which of the following option will be the limiting molar conductivity of acetic acid CH3COH if the limiting molar conductivity of CH3CONA sodium acetate is 91 Simon centimeter square mole inverse. Okay, so we have to select the option which is representing the limiting molar conductivity of acetic acid, and we know the limiting molar conductivity of sodium acetate, which is 91. The limiting molar conductivity of individual ions are given in the following table. We have also given a table here where the ionic limiting molar conductivities are given for the individual ion. For the H positive, the limiting molar conductivity is 349.6 Simon centimeter square mole inverse. This is the unit of limiting molar conductivity measurement. Okay, S representing Simon. Next ion is the sodium positive, which you can get from the sodium acetate, whose limiting molar conductivity is given as 50.1. Potassium positive ion, which has 73.5 limiting molar conductivity value. And then we have OH minus, which is having 199.1 limiting molar conductivity value. Okay, so these are the value of the limiting molar conductivities of different individual ions which you can get from acetic acid and the sodium acetate when you do the dissociation process with both of them, right? So you have already given the limiting molar conductivity of sodium acetate and you have to find the limiting molar conductivity of acetic acid. This question has been in the CBSE examination in SQP in the session 2020-21. SQP means sample question paper. Now you have given the 4 choices for the value of the limiting molar conductivity of acetic acid. They are 350 Simon centimeter square mole inverse, 375.0 3 Simon centimeter square mole inverse, 390.5 Simon centimeter square mole inverse, or 340.4 Simon centimeter square mole inverse. So try to relate the limiting molar conductivities concept we have been covered, and the limiting molar conductivity of individual ions, why they are given, how can we relate it to get the limiting molar conductivity of whole acetic acid. This you have to think of. So you got some time, try to solve this, and then we will continue to the correct answer. Okay, let's see. So for this given question, the correct answer is option C, which is 390.5 Simon centimeter square mole inverse. Let's solve it. The limiting molar conductivity given by lambda naught m for the strong and the weak electrolyte can be determined by using Kohlrausch law. Okay, so as the Kohlrausch law relates, or you can say as the Kohlrausch law gives us the relation between the molar conductivity and limiting molar conductivity, right, for the various ions. So you can say that the limiting molar conductivity for the strong and the weak electrolyte can be determined by using Kohlrausch law, which states that the limiting molar conductivity of an electrolyte can be represented as the sum of the individual contributions of anion and cation of the electrolyte, right? So what you have to do, you just have to take the sum of individual contribution of anion and cation uh, of their limiting molar conductivity. Okay, so if you want to find out the limiting molar conductivity of acetic acid, so CH3CONa will dissociate into CH3CO minus and Na plus, right? And CH3COOH will dissociate into CH3COO minus and H plus, right? We have given the H plus limiting molar conductivity and the Na plus limiting molar conductivity. Okay, so we have already know the limiting molar conductivity of CH3CONa. You can put that this equals to the 91, right? For sodium we know, which is 50.1. You just have to put that value here and then subtract it from the 91. Then you will get the CH3CO negative limiting molar conductivity, which is 91 minus the molar conductivity of sodium positive, which is 50.1. Whatever the answer you will get, that is the limiting molar conductivity of CH3CO negative ion. Then you can use that to determine the limiting molar conductivity of CH3COH, because CH3CO minus the limiting molar conductivity value, which you determine here, you will put it here in this equation, and H positive limiting molar conductivity will be 349.6, right? Then you will sum them and the answer which you got will be the limiting molar conductivity of the acetic acid, okay, which is nothing but 390.5 Simon centimeter square mole inverse. So simply we apply the Kohlrausch law. So lambda naught of this whole electrolyte CH3CONa will be the sum of lambda naught of CH3CO minus plus lambda naught of sodium plus, right? As I said that we have to apply the Kohlrausch law, which is we are applying. Kohlrausch law was given that lambda naught will be equals to the nu positive lambda naught positive plus mu negative lambda naught negative, where nu is representing the number of the positive or the negative ions which we are getting after the dissociation, right? But CH3CONa will dissociate into CH3CO minus and Na plus, so one positive cation and one negative anion we are getting, so we are multiplying here by 1 in this equation, right? So we are not need to write it here because 1 times something will be something. So we just apply the Kohlrausch law, which is lambda naught of this electrolyte equals to the sum of their ionic limiting molar conductivities. Then we know the sodium positive limiting molar conductivity, so we put that here 50.1. We don't know about this, but we know about this already given in the question, which is 91 Simon centimeter square mole inverse. From this we can get the lambda naught of CH3CO minus, because this is only the variable here. So lambda naught of CH3CO minus will come out as 40.9 Simon centimeter square mole inverse, right? So now for the acetic acid means CH3COH. Now because in the question it is given no that limiting molar conductivity of CH3COH you have to identify from the option. So for the acetic acid, the lambda naught of acetic acid is given by the lambda naught of CH3COH, that is the limiting molar conductivity of an ion plus limiting molar conductivity of cation. Here also 1 is in the multiplication, but we are not needing to write it, because 1 times something is something, right? So again we are applying the Kohlrausch law, and as you know that we just have found out that what is the lambda naught of CH3CO minus, right? So we put that here, and lambda naught of H positive is we take from this given table, which is 349, and then you can easily sum them and determine the lambda naught value for acetic acid. So it will be 40 plus 349.6, so this will be given by 390.5 Simon centimeter square mole inverse, right? So for the acetic acid, the lambda naught, that is the limiting molar conductivity for the sodium acetate, is given as for the acetic acid is given as 390.5 Simon centimeter square mole inverse, and hence this will be the correct answer. Okay, so let's move on to the next one. Okay, now this is a CBSE PYQ which we have taken, and this covered the section 2.4 of the NCERT textbook in the chapter Electrochemistry. So the question says that when 0.1 mole of COCl3 NH3 whole 5, this product, is treated with the excess of silver nitrate AgNO3, 0.2 mole of AgCl are obtained. So understand the question. We have given 0.1 mole of this compound, and when this quantity of this compound is reacted with the excess amount of AgNO3, this amount, that is 0.2 mole of AgCl, are the product that we obtained. The conductivity of the solution will correspond to, now you have to tell the conductivity of the solution. Okay, so we have given the 4 choices here, which is 1:3 electrolyte, 1:2 electrolyte, 1:1 electrolyte, or 3:1 electrolyte. So these are the 4 choices given. You have to select that when you treat this compound, this much amount of compound with excess of AgNO3, you are getting this amount of AgCl. So what will be the conductivity of the solution that you will be obtained, right? So you just apply here the conductivity rule in which the concentration is involved. Okay, so try to relate that with the theory which we have already covered, and then you can get the answer. So you got some time, go through it, and then we will see the correct answer. Okay, so let's see its correct answer. So for this given question, the correct answer is option B, that is 1:2, that is 1:2 electrolyte. Try to solve it. So when we take this much amount, that is 0.1 mole of COCl3 NH3 whole 5, then it was reacted with excess of AgNO3, and then we are getting 0.2 mole of AgCl. This was the information provided in our question. So there are 2 chloride ions that are free and not part of the complex. Okay, so as per the given information in our question, we have determined that because let's say this is multiplied by the 10, okay, so 0.1 will become 1 and 0.2 will become 2. Let's say this is 1 mole and the 2 moles. So when 1 mole of this compound is reacted with AgNO3, we are getting 2 moles of AgCl. What does that means? That means that there are two chloride ions which are free and not the part of the complex. So the formula for the complex has to be CO, that is cobalt, NH3 whole 5, Cl and Cl2 are extra. Okay, so so two extra, or you can say two free chloride ions are present outside of the complex, which is not the part of the complex, because they are taking the participation in the reaction with AgNO3 and converting to AgCl, right? That's why we are saying that the formula for the complex has to be this: CONH3 whole 5 Cl Cl2, right? So if you remember, or if you we are gonna study about this, that in the coordination compound we have a complex inside this square brackets, and whatever the outside of this square bracket is present, that can be ionizable, but whatever the thing is inside of this square bracket, that cannot be ionizable when dissociation will happen. Okay, so that means CONH3 whole 5 and chlorine, they will not dissociate, like they will not go out and like CO2 plus NH3 something plus Cl minus, they will not do that. Okay, they will not dissociate. Basically, CONH3 whole 5 Cl will go as it is in the water or in the solvent and remain as it is, but Cl2 will dissociate from here and form 2Cl minus ions, which will going to react with AgNO3 when you are treating the complex with the excess of AgNO3, and then the compound is forming, which is 0.2 moles of AgCl. This chloride ions will react with AgNO3 and form AgCl as product. So this is the reaction, which is cobalt, NH3 whole 5 Cl, Cl2. Now this is giving us after dissociation 2 ions or 3 ions. First is this complex ion, which is CONH3 whole 5 Cl whole 2 positive, plus 2 ions of chlorine. So 2 chloride ions, 2 Cl negative. Okay, this is the dissociation for the product or the electrolyte, which has already given in our question. What you have to tell the conductivity of the solution, that will be corresponding. So the conductivity of the solution will be 1:2 electrolyte, because 1 we are getting this ion and 2 we are getting this chloride ion, that is 1 positive 2 negative. So 1:2 electrolyte is the conductivity of the solution, right? So from the options, it correctly match with the B option, so B option is the correct answer. Okay, now let's move on to the next question. Okay, this is a CBSE PYQ question based on the NCERT section 2.4 in the chapter Electrochemistry. So the question has two statements, assertion and reason, and you have to identify that which option will suit them, or which option will be the correct one as per the given statements of assertion and reason. Reason statement is generally to specify or to prove the assertion or to explain the assertion statement. Okay, so assertion statement is conductivity of an electrolyte decreases with decrease in the concentration. So it is saying that conductivity of an electrolyte will decrease when you decrease the concentration of the electrolyte. Reason is, on dilution, the number of ions per unit volume is decreasing. Okay, so this is the reason that when you are diluting the solution, the number of ions per unit volume, that means in 1 liter volume or 1 meter cubic volume, the number of ions is also decreasing with the dilution process. This is the reason. So you have to check the assertion statement, and then you have to check the reason statement, and you have to identify that whether reason is explaining the assertion statement correctly or not. The options given are both assertion and reason are true, and the reason is the correct explanation of the assertion. Both assertion and reason are true, and reason is not the correct explanation of assertion. Assertion is true, but reason is false, or both the assertion and the reason are false. So you have to select the correct options regarding these two statements. Okay, so try to solve it and try to relate the conductivity with the concept we have studied about the conductivity and the dilution or concentration process, right? And then you can get the correct answer. So you have some time, go through it, then we will see the correct answer. Okay, let's see. So for this given question, the correct answer is option A, which says that both the assertion and the reason are true, and the reason is the correct explanation of the assertion. Now let's see how. So explanation is that conductivity, which is also represented by kappa, is a measure of solution's ability to conduct electricity. Okay, now if you define the conductivity in simple term, this means that whether the metal or the thing is conductive or not. That means whether the electricity could pass through it or not, right? That was the basic thing which we have studied about the conductivity. Now conductivity, which is a kappa, is a measure of solution's ability to conduct electricity. So we have a solution. Here we are talking about electrolytic solution. So whether our electrolytic solution is capable to conduct the electricity or not, to generate the electricity or not. So this solution's ability measurement is determined or is seen by conductivity, which depends on concentration of ions in the solution. Now in the solution, as you know, we use electrolyte or ionic electrolytes where the ions will dissociate, right, from the electrolytes. That means in our solution the ions are present for the electrolytes, different ions, negative ion, positive ion. So whether the solution can conduct electricity or not, this ability measurement is determined or is depend on the concentration of the ions which are present in our solution. What is the concentration of ion present in our solution, whether they are more or lesser? Because if it is lesser, then we can conduct or the solution can conduct lower electricity, lower amount of electricity, then it can conduct when the concentration of ions are larger, right? So conductivity depends upon the concentration of ions present in the solution. So when an electrolyte is diluted, so when you dilute the electrolyte, that means when you add more solvent to the electrolyte, to the solution, the concentration of ions, cations and anions both, in the solution is decreasing because you are diluting, right? You are diluting the solution, you are adding more solvent, then the concentration of ions in solution will decrease, right? For example, if we dilute a solution of sodium chloride, another name is table salt, right? So if you take a salt solution, table salt solution or NaCl solution, and when you dilute it, the number of sodium positive and chlorine negative ions per unit volume decreases. If you make a salt solution, or you can say if you make a table salt solution in your home, which the salt is like a little bit more, then what you can do to neutralize it, you can add more water to it to neutralize the taste of the table salt solution, right? Simply we are saying that when you dilute a solution of sodium chloride, number of sodium and the chlorine ions, that is sodium positive and chlorine negative ions per unit volume decreases, which is why the concentration is also decreasing on dilution, and it will going to affect the conductivity of the solutions, right? So that is why the correct answer is option A, which is both assertion and reason are true, and the reason is the correct explanation of assertion, because assertion is saying that conductivity decrease with decrease in concentration, which is correct, right? Now reason is saying that on dilution process number of ions per unit volume decreases. Now the reason is also correct statement, but the reason is also the correct explanation of the assertion statement, right? So that is why the correct answer is option A. Okay, moving on to our next one. Okay, this is again a CBSE PYQ covering the NCERT textbook section 2.4.1 in the electrochemistry chapter. This question also has an assertion statement and a reason statement. Assertion statement is given as lambda m for weak electrolytes shows a sharp increase when the electrolytic solution is diluted. The reason is for the weak electrolytes, degree of dissociation increases with the dilution of the solution. Okay, so assertion is given as that lambda m for weak electrolytes. The weak electrolytes means which not completely dissociates into the solution, that is lambda m. So lambda m for the weak electrolyte show sharp increase. Sharp increase means sudden increase when the electrolytic solution is diluted. So if you see the graph, okay, let's say we have a graph in which this is the graph of the, you can say lambda m of weak electrolyte, then suddenly the graph will increase. That means it is showing a sharp increase. Why? Because the electrolytic solution is diluted. This is given as the assertion statement. Now the reason statement is that for the weak electrolytes, the degree of dissociation is alpha. We have studied. Okay, degree of dissociation is basically the amount or the capability of a ion of a salt to dissociate into the ions. Okay, so that is alpha, that is degree of dissociation. So it is saying that for the weak electrolytes, degree of dissociation is increased with the dilution of the solution. When you dilute the solution, alpha will increase for the weak electrolytes, in case of weak electrolytes. Okay, now you have to identify whether the statement given in the assertion is correct or not, or the statement given in the reason is correct or not, and also if the reason statement is explaining the assertion statement or not. The options given are both the assertion and the reason are true, and the reason is correct explanation of assertion. Both assertion and reason are true, and reason is not the correct explanation of assertion. Assertion is true but reason is false, or both the assertion and the reason are false. These are the four options, four choices you have. You have to select the one which is correctly matching with the given two statements. So you have some time, go through it and then try to conclude at one option. Then we will see the correct answer after some time. Okay, let's see. So for this given question, the correct answer is option A, that both the assertion and the reason are true, and the reason is correct explanation of the assertion. So let's see how. Now explanation is that molar conductivity represented by lambda m, which is already about which we are already talking in the question. So molar conductivity, that is lambda m, is defined as conductivity of the solution divided by molarity of the electrolyte. Okay, so what we are saying, that molar conductivity is defined as the conductivity of the solution divided by the molarity of electrolyte which we are using. It indicates how well the ions in the solution can conduct electricity. Now, molar conductivity tells you that how betterly the ions in the solution present can conduct electricity. So, when a weak electrolyte, we are talking about weak electrolyte in the question also, right? So, when a weak electrolyte is diluted means we are increasing the solvent quantity. So when a weak electrolyte is diluted, the concentration of ions A positive and B negative, if we are considering AB as a salt or electrolyte. So the weak electrolyte is diluted, that means the concentration of ions of A positive and B negative in the solution will decrease. The concentration will decrease with the dilution process. This is simple, right? However, degree of dissociation, that is alpha, increases with the dilution process. Okay, so degree of dissociation, that is alpha, increases with the dilution process in the case of weak electrolytes, but their concentration on the dilution will decrease. This means that more of weak electrolyte dissociates into ions as the solution becomes more dilute, right? So as the weak electrolyte more dissociate into the ions, as the solution will become more dilute. Okay, so as much as we dilute the solution, the weak electrolyte solution, you can say, so weak electrolyte solution, if you dilute it, as much as you dilute it, the more weak electrolyte will dissociate into different ions. That means their degree of dissociation will increase, their capability or their ions will increase in the solution. Therefore, on the dilution process, their degree of dissociation increases, and hence their lambda m, that is the molar conductivity, is also increasing sharply. As this is the explanation, so the assertion statement, which is that lambda m for the weak electrolyte show sharp increase when electrolytic solution diluted. This is the correct statement. This is true. Reason which says that weak electrolyte degree of dissociation increase with dilution of the solution, this statement is also a true statement, right? So both the statement are true, and also the reason statement is the explanation or correctly explaining the assertion statement. That is why we have the correct answer as option A, which is saying that both the assertion and the reason are true, and the reason is correct explanation of assertion. Okay, let's move on to the next one. Now, this question is again a CBSE PYQ, and it covers the NCERT section 2.4.2 in the electrochemistry chapter. Question says that what is meant by the term of infinite dilution? This is the term infinite dilution. What do you mean by this? What is mean by infinite dilution? So this is the question. Basically, you have to define the infinite dilution, what you will understand or what you are understanding from the term infinite dilution. So you have some time, try to write it, and then we will see that how can you answer it. Okay, let's see. So for this given question, the correct answer will be that you have to define the infinite dilution, right? So correctly you can define it like the term infinite dilution means a solution that is so dilute that it has maximum or limiting molar conductivity, which does not increase on further dilution, right? So infinite dilution means a solution is so dilute that maximum it has maximum conductivity, or it has limiting molar conductivity, which does not increase on further dilution process. It has achieved the infinite dilution. Okay, this you can derive from the Debye-Huckel-on-Segur equation, which is lambda equals to lambda naught minus a under root c. So if this c concentration is approaching to 0, and when it approaches to 0, when you are diluting our solution, then this concentration will approach to 0, and this term will become 0, and the lambda will become equals to its maximum possible value, which is lambda naught. Right? So this is the term, this is the condition where we can call it as infinite dilution. Solute particles such as ions in an electrolyte are so far apart that there are no interactions between them, and at the infinite dilution condition, the solute particles are so much far apart from each other. That means no interactions between them can be possible. Each ion behaves independently and its properties are not influenced by the presence of other ions. As I said, that the separation between the two ions or the solute particles will become so large that they will behave independently, they will show their properties independently, and they will not influenced by the property of the other ion or the presence of the other ion, right? So this is how you can define the term infinite dilution, right? Okay, so let's move on to the next one. Now this is a numerical type question. This is covering NCERT section 2.4.1 and 2.4.2. Question is, conductivity of 10 to the power minus 3 mole per liter acetic acid at 25 degrees Celsius is 4.1 times 10 to the power minus 5 Simon centimeter inverse. Calculate its degree of dissociation if the lambda naught m for the acetic acid at 25 degrees Celsius is 390.5 Simon centimeter square mole inverse. So you have to calculate the degree of dissociation, that is alpha, right, on the basis of given values. Okay, so you got some time. Try to solve it by applying some formula which are relating the conductivity and the degree of dissociation for a particular electrolyte, and after this some time we can see the correct answer. Okay, let's see. So for this given question, how can you answer it? You have to just use some formulas. So let's see. So molar conductivity is given by kappa by C, that is conductivity upon the concentration. Concentration is given, which is 10 to the power minus 3 mole per liter. You can identify even by the units. This unit is associated to the concentration. And the conductivity is given as 4.1 times 10 to the power minus 5. So you can get the lambda m, that is molar conductivity. So for the unit conversion, we are putting every units in this formula, and also we are multiplying the 1000 by the conductivity in the numerator for the unit conversion, and the lambda m, that is the molar conductivity, will become 1000 centimeter cube liter inverse multiplied by the kappa. Kappa is 4.1 10 to the power minus 5 Simon centimeter inverse divided by the concentration, which is 10 to the power minus 3 mole per liter. When you solve this fraction, this will be equals to 41 Simon centimeter square mole inverse. Okay, so this will be the lambda m value. Okay, when you just use this. Okay, so when you solve this equation or this fraction, the lambda m, which is the molar conductivity, is coming out as 41 centimeter square mole inverse, right? So this liter inverse cancel out, mole will remain, it will go in the numerator, become minus 1. centimeter to the power -1 and 3 will become square, right? So for this unit conversion, we use the 1000 multiplication here, and we get the final value for the lambda m. Now we can use it to determine the degree of dissociation. So degree of dissociation alpha is given by lambda m c divided by lambda naught m. So molar conductivity divided by the standard molar conductivity. Okay, so we have already given the acetic acid lambda naught m value, which is 390.5. so alpha you have to determine, and we have already got the lambda m. Okay, so alpha will be the lambda m, which is 41, upon the lambda naught m, which is 390.5, and when you solve this fraction, this is equals to 0.105. so this is the value of the degree of dissociation alpha for acetic acid, and our final answer. Okay, so this is how you have to just relate the given values in the numerical. Here in this case, we have given the concentration and the conductivity and the limiting molar conductivity. So you just have to relate all these terms with the formulas to determine the degree of dissociation, right? And stepwise you have to calculate the values. As you can see, we first calculate the lambda m, because we know the degree of dissociation, which is lambda m by lambda naught m. Lambda naught m is given, lambda m is missing. Now for lambda m, the formula is kappa by c. Kappa is given, c is given, so you can determine lambda m, and then you can use it to determine the alpha, right? So this is the correct answer, 0.105. Okay. Okay, so that's all for today's chemistry session. Thank you so much for joining this session. Thank you.